right, this is section 12.2. We're multiplying, dividing rational expressions. This again has been covered in sections 8.1 through 8.5 on multiple times. And so I'm going to go through a very quick example here, reviewing multiplying, and then I'm going to allow you the time to do the examples B, C, and the D that you can't quite see here. So let's first of all review the process, and then I'll scroll this up so you can see that. Step number 1, factor the numerators and denominators completely. Step number 2, cancel if possible. Step number 3, multiply the denominators. Step number 4, multiply the denominators. Now, in multiplying the numerators and the denominators, some books will just simply place those as multiplied in theory, and others will physically multiply them out. Typically, a basic algebra book will multiply them out in their entirety, multiplying polynomials by one another. In intermediate algebra text, they usually symbolically multiply. So first of all, we want to factor. And the numerator of this first one does not factor, so I simply copy it, x plus 1. And then the denominator, x squared plus 7x plus 6, the factors of 6 that sum to 7. So we have an x with a 1 and an x with a 6. And then they're both going to be pluses because they're summing and the middle term's sign is positive. Now, in the next one, our numerator again is not going to factor. So we have x plus 1 just written down. And then the denominator, we see a binomial. And the binomial is a sum, and I see a cube. So is it cubes? Yep, that's a perfect cube. Yep, that's a perfect cube. So the sum of two perfect cubes factors, remember, as the root and the root in a binomial with the same sign as our original binomial. And then the root of the first term gets squared, and then it's minus the product of these two roots, and then it is this root squared. And it's always plus that last one. And so that's what it looks like. Remember that this is going to look really similar to a perfect square trinomial, but it is not a perfect square trinomial. And now last but not least, we want to cancel. So canceling one of these with one of those. Remember, you can't cancel both of them. You only get to cancel one of them. And now we rewrite it. Now an intermediate algebra text would simply rewrite it as x plus 1 over, and then you would see x plus 6 times x plus 2 times x squared minus 2x plus 4. However, many beginning algebra or just basic algebra texts would actually multiply this all out. And so in other words, this they would multiply back out to be x cubed plus 8, and then they would multiply that by x plus 6, and we can do that with long multiplication, 6 times 8, which is 48, and then we get 6x cubed way out here, right? And then we have x times 8x, which is right here. And then we have x times x to the x cubed, which is x to the 4th. And so we would have all of these summed up, right? And so we would rewrite this as x plus 1 over, and then we would have an x to the 4th, and then plus, we have x, 6x to the 3rd, and then we would have plus 8x, and then we would have plus, and I don't know if I can even get that squeezed in there, plus, I'm not going to, so I'll have to put it down here, 48. And so that would be what that would look like in a beginning algebra text. That's many times how they would write it out. I'm okay with you writing this one right here. That's okay with me. And so whatever your text looks like, that's what you kind of should keep things as a baseline to that. So if you're using our text is leaving it like this because it is a basic algebra text / intermediate algebra text, so they are leaving it multiplied out. But again, if you're using a different textbook and watching my video, do keep an eye out for that because you'll see the differences there. All right, so that's a review of multiplication, and the review of multiplication. Now I think you should copy down B, C, and D, do those on their own, and then come